Hey, I want to do a quick video about conditional probability. A lot of students are coming across this right now. I don't have that much prepared, so I'm going to do off the top of my head, but this is a really important topic. Hopefully I'll be able to replace this video later with a more laid out, proper video, but it's so important that I think I just need to go ahead and get this out there. For those of you that are struggling to get through your homework. Hopefully I'll have a better video by the time you take your test. So conditional probability. This is probably the hardest thing you will do in finite math. When I say it's the hardest, it's not necessarily the hardest to compute, but it's the hardest to conceptually understand what it is that you're trying to calculate. Okay? So conditional probability are problems where they say the phrase, given that. Can you see that? Yeah. Okay. Given that this occurred, what's the probability that this will occur? Questions like that. That's how you know that you're dealing with a conditional probability question. Otherwise, it's just probability. But this is a probability question, so it's probably worth our time to go over what is probability in the first place real quickly. So, given that, when you see that phrase, you know you're dealing with conditional probability. What is a probability? So, real quickly, the probability of an event occurring is the number of ways the event can occur over the number of the sample space. Number of ways of the event, whatever it is you're looking for, the number of ways that can occur over the total sample space, your total universe, okay? Now, what is a conditional probability? A conditional probability is A given that B happened, okay? We say that this line here is given that. Given that occurred, okay? Alright, so what's the probability of A given that B occurred? That is, so by definition, what's the probability of an event occurring? It's the probability of A intersect B over the probability of B occurring. So this is what this means. Okay. What does that mean? That's the number of ways that A and B can happen over the number of the sample space over the number of ways B can occur over the number of the sample space. Quite a bit. Okay? The number on which ways they both can happen over the sample space, the number of ways B can happen over the sample space. But, as you can see, that's going to cancel out. So you're really just looking for the number of ways that A and B can happen at the same time over the number of ways B can happen. So your sample space has considerably reduced. Now you're not looking for the number of ways in the universe, but you're just looking for the number of ways B can happen. Okay? So conditional probabilities, the probability goes way up. Okay? It's kind of the difference between what's the probability you'll win the lottery versus what's the probability you won the lottery given that someone in the room won the lottery. So now you don't have to compare yourself to everyone that played the lottery, but just the people that are in the room. So the probability of you winning the lottery goes way up. Okay, let's look at some examples because that's, the devil's in the details. Everything else is basically a story, but, that's where you're going to get tripped up. Alright, well, we know that they love to do questions like you have 4 blue balls, and you have 3 green balls, and you have 2 yellow. Okay? Let's find the probability that, well, how many are we going to choose? We have to do that first. So let's say you select 3. You're gonna select 3 total. All right. What's the probability that you selected at least 2 blue, given you selected at least 1 blue? What's the probability that you selected at least 2 blue, given that you selected at least 1 blue? Alright? So what we're actually looking for is the number of ways this can occur at the same time, divided by the number of ways this can occur. Alright? So how many ways can you get at least 2 blue and at least 1 blue? Well, if this condition is satisfied, then this condition is satisfied. So another way you can think of it is, we just want to know how many ways can that happen. Alright? We're selecting 3 balls total. So let's see. At least, that's another part of your least favorite phrase. It means we're going to have multiple scenarios. So, at least 2 blue. So, you have 4 blue, 4 choose 2. Then, you have to select 1 more. Have to. That's going to come out of the green and the yellow, which there's 5 of those, and you're choosing 1. Okay? These are going to be multiplied because they're the same scenario, the same instance. Then we're going to add on the idea that you could have selected all blue. 4 choose 3. Okay? Now, that is the number of ways your event can occur. I should probably put this another way. This is the number of ways that A intersect B can occur, and now we need the number of ways that B can occur. So, how many ways can B happen? B is at least 1 blue. Okay? Now I'm going to go the straightforward approach in this problem because I think it's going to be complicated enough where you don't necessarily want to see more tricks. So let's do it. At least 1 blue. Well, I could have picked 1 blue. That's 4 choose 1 times, and then I have to pick out of these 2, 5 choose 2. I could do 4 choose 2, 5 choose 1, and I could do 4 choose 3. That's your denominator. Okay? Another way you can do it, the easier way, is to take the total. You got what? 4, 7, 9. 9 choose 3 minus the event you don't want, which is 5 choose 3. That you could also write that this is your denominator. This is the total sample space. This is the event you don't want to occur. So this is an easier way to get this answer. Okay? And as a matter of fact, I'm just going to replace this with this so you can kind of, it'll be easier to calculate. Alright, so 9 choose 3 minus 5 choose 3. Alright, the rest is just calculating. So let's do it. Well, 5 choose 1 is just 5, and 4 choose 3 is just 4. So let's make a little note that we just know those. Now I'm going to have to do some ones I don't know as well. Let's see. I think this is just 6. I can't tell if you guys see that. So maybe I should just do it. So 4 choose 2 is 4 factorial, 2 factorial, 2 factorial. So that's going to be 4 times 3 divided by 2, 6. So that's 6. So we got the numerator totally taken care of now. We'll just need to multiply and divide, or multiply and add. Now we need to figure out 9 choose 3. That's 9 factorial, 9 minus 3, 6 factorial, and 3 factorial. Okay, now you're going to have 9 times 8 times 7 over 3 times 2 times 1. Cut the 3. So now you got 12 times 7, that'd be 70 plus 14. What did I say? That's 84. Sorry. 84. Okay. 5 choose 3. You might know this one. 2 factorial, 3 factorial, and then now you got 5 times 4 divided by 2. That's 10. So you got 74 on the bottom. So now what do you got? Now you got 6 times 5, that's 30, plus 4 over 84 minus 10, 74. Now you got 34 over 74. And what's that? That's 15 plus 2, that's 17 over 35 plus 2, 37. 17 37ths. I'm sure you can just do it on your calculator. But the important thing is that you see how this is built up. Okay? I hope I didn't lose you. I probably did. It's so easy to lose people when you're talking about conditional probability. So you know what? Let's just do another one, and let's just use the same scenario but different problem. So let's use the same setup, and we're still selecting 3, because I just want you guys to understand what conditional probability means. Just in case I lost you on the last one, let's do an easier problem just to be sure that you're following along. So let's say you want to know the probability of drawing 2 green given you drew 1 yellow. I probably should start with this. What's the probability that you're going to draw 2 green given you drew 1 yellow? So what's this? The number of ways you can draw 2 green and 1 yellow over the number of ways you can draw 1 yellow. Alright. Now, now you're picking 2 green. You have 3 total. 3 choose 2. And you're picking 1 yellow out of 2. 2 choose 1. So that's the numerator. Now how many different ways can you pick 1 yellow? We have 2 yellow. So 2 choose 1. We have to select 2 more. It's going to have to come out of the green and blue. You have 7. 7 choose 2. So there's your conditional probability of this problem. Alright. So 3 choose 2 is just 3. 2 choose 1 is just 2. So you got 6 on the top. Then you got 2 choose 1. That's just 2. And then 7 choose 2. I can't remember. Oh, let's do it. Alright. 7 factorial. 5 factorial, 2 factorial. That's 7 times 6 over 2 times 1. That comes 321. That's 2/7. Okay. Okay. So there's another problem. Let's do another one with the same scenario. In fact, let's flip it. Let's flip it. What if it was probability of 1 yellow given 2 green? Okay. So when they ask you and they flip these, be sure you understand that they're not the same thing. Parts of it are the same thing, but generally it's not going to be the same probability. So, what does this mean? What changed? Their intersection is the same. Okay? Just like we were doing in chapter 1, the intersection of A and B is the same thing as the intersection between B and A. It's the same intersection. So that was generally true for all systems. So it's true that either way you go, it's the same intersection. But what changed is the denominator, your conditional sample space. So we need to know how many different ways can you get a 2 green. Okay? So the number of ways to get 2 green becomes, let's see. So you have 3 green, 3 choose 2, and then we have to choose one more, and that comes out of blue and yellow, and you've got 6. 6 choose 1. This is your new conditional sample space, and that is just 3 times 6, which is 18. Alright, well, this is still the 6 from before, but it becomes 18, and you get 1/3. Okay? So, the probabilities changed. But what changed was what was guaranteed. So before, it was the yellow that was guaranteed, but now it's the green. However, the numerator stays the same. The denominator is what's changing. Okay? I really hope this helps. Conditional probability is probably the most complex idea that you're going to do in the whole class. I plan on doing some more examples of this later, but I guess that'll be it for now. Until next time, just let me know in the comments or email me if there's any particular problems you're struggling with, and I'll try to make a video of that. Okay? So just let me know. Until then, I'll see you later.